Hello everyone, welcome back to our math room. In this video, we will have once again a lesson in general math made easy with teacher Joanne. And the topic is all about graphing logarithmic functions and finding their properties. What are the learning objectives? At the end of the lesson, you should be able to represent logarithmic function through its table of values, graphs, and equations, find the domain, range, intercepts, and asymptotes of logarithmic functions, and graph logarithmic functions. So what is a logarithmic function? It is denoted by f of x is equal to the logarithm of x with base a and is the inverse of an exponential function of the form x is equal to a raised to y for x is greater than 0, a is greater than 0, and a is not equal to 1. Here are the examples of logarithmic functions. First, we have f of x is equal to the logarithm of x with base 2 and f of x is equal to the logarithm of x with base 1/2. Looking at the first example, the base here is greater than 1, while the base here in our second example, it is greater than 0 but less than 1. So how are we going to graph a logarithmic function? First, we need to make a table of values. Second, we plot the points found in the table of values. And third, we connect all the points using a smooth curve. Let us first sketch the graph of the function f of x is equal to the logarithm of x with base 2. This is an example of a logarithmic function having a base that is greater than 1. So the first step is to have the table of values. Here in the table of values, we should have values of x that are greater than 0. Why? Because when we use 0 or negative, the answer is undefined. So in our table of values, we have 1/8, 1/4, 1/2, 1, 2, and 4, which are all greater than 0. And to solve for the f of x, all we need to do is just to plug in each value of x to our given function. To begin with, let us have 1/8. So we have f of 1/8 is equal to the logarithm of 1/8 with base 2. Now, let us change 8 to a power of 2, which is 2 raised to 3. Using the negative rule in the exponent law, this 2 raised to 3 will now become 2 raised to negative 3 by putting this denominator to our numerator. Next, using the property of logarithm, when the base 2 is equal to the x, which is 2 here, the answer is the exponent of the x, which is negative 3. So 1/8 as the value of x, its f of x is negative 3. Next is 1/4. So we have f of 1/4 is equal to the logarithm of 1/4 with base 2. Let us change 4 to a power of 2. So we have logarithm of 1 over 2 squared with base 2. Next is to remove the fraction using the negative rule in the exponent law, so it becomes 2 raised to negative 2. And using the property of logarithm, when the base a is equal to x, the answer is the exponent of x, which is negative 2. So we have negative 2 as the value of f of x when x is 1/4. Next is 1/2. So we have this. Next is remove the fraction. So this becomes 2 raised to negative 1. And since the base is equal to the value of x, the answer is the exponent, which is negative 1. Next value, we have 1. So when we substitute, it will become logarithm of 1 with base 2. Here, to get the value of this, we need to apply the property of logarithm. In taking the logarithm of 1, it is always equal to 0. Next is when x is 2. So we have f of 2 is equal to the logarithm of 2 with base 2. Since the base is equal to x, then the answer here is 1, which is the exponent. Next, we have x equals 4. So we have f of 4 is equal to the logarithm of 4 with base 2. Change 4 to a power of 2, so it will become this. Then since the base is equal to x, then the answer is the exponent, which is 2. After completing the table of values, the next thing to do is to plot the points. So here we have 1/8 and -3. So let's locate it. Let's say this is 1/8 and then find -3 on y. So we have this point. Next we have 1/4 and -2. Next we have 1/2 and -1. Next we have 1 and 0, 2 and 1, 4 and 2. After plotting the points, the third step is to connect all these points using a smooth curve. So here is the graph of the given function, logarithm of x with base 2. Now, based on our graph, let us find its properties. So first, the behavior. As we can see, the values are increasing. As x increases, y increases. Therefore, the behavior is increasing. And this happens when the base is greater than 1. Next, let us find the domain. As we can see on our graph, we only have values that are found at the right of 0. So we have these points, then 1, 2, 3, and so on and so forth. Therefore, the domain is x greater than 0. How about the range? Observe the values of y. Here, the graph is increasing, meaning to say it goes upward continuously. At the same time, this portion is moving downward continuously. So the range of this function is a set of real numbers. Now, let us identify the intercepts. As we can see on our graph, we have a point of intersection of the graph and the x-axis, which is at 1 and 0. Therefore, this becomes the x-intercept. While for the y-intercept, as we can see, the graph did not touch the y-axis. Therefore, the y-intercept is none. So again, the x-intercept is at 1, 0, while the y-intercept is none. Next, let us find the asymptotes. As we can see on our graph, the graph did not pass the y-axis. Therefore, we can consider the y-axis as the vertical asymptote, which is given by x equals 0. As for the horizontal asymptote, as we can see, the graph moves upward continuously and it moves downward continuously. Therefore, we do not have a horizontal asymptote. So again, for this function, the vertical asymptote is at x equals 0 and there is no horizontal asymptote. Now, let us recall the graph of the exponential function y is equal to 2 raised to x. How will you compare it with y is equal to the logarithm of x with base 2? Based on our previous discussion, we have the graph of the exponential function y is equal to 2 raised to x. And as for the domain of any exponential function is a set of real numbers. And as for the range, based on this graph, we can see that the values of y are found above 0. Therefore, set of y such that y is greater than 0. Now, let us compare the two functions. Take a look at this Cartesian plane. As we can see, we have the graph of the logarithmic function, logarithm of x with base 2, and the exponential function, f of x is equal to 2 raised to x. In our previous discussion, we said that logarithmic function and exponential function are inverses of one another. How do we know about it? Let us have the line of symmetry. So this is y is equal to x. If we're going to fold this Cartesian plane with respect to this line, will these two graphs coincide? It's a yes. And if we're going to look at the points here, we have a point that is 4, 2 on this graph, and its inverse is 2, 4, which is found on this graph. Therefore, they are really inverses. And if we're going to compare the domain and range, the domain of this function is the range of this function, and the range of this function is the domain of this function. So we have this domain and the range of our logarithmic function. And for the exponential, we have this, which is the range here, and the range, which is the domain. So again, this shows or this proves that the exponential and logarithmic functions are inverses. Let us now move to our second example. Sketch the graph of the function logarithm of x with base 1/2. Looking at our given example, it is a logarithmic function where the base is between 0 and 1. So the first thing we need to do is to have the table of values. And again, we cannot have a value of x that is 0 or negative. So in our table of values, we have values that are greater than 1. 1/8, 1/4, 1/2, 1, 2, and 4. And to solve for the f of x, the thing is to input the value of x to our given function. First, let's begin with 1/8. So we have f of 1/8 is equal to the logarithm of 1/8 with base 1/2. Now let us express 1/8 as 1/2 raised to the power of 3. Next is, since the base is equal to the value of x, then the answer here is the exponent, which is 3. Next is when x is 1/4. So we have this. Change 1/4 to 1/2 raised to the power of 2. Since the base is equal to the value of x, the answer is the exponent, which is 2. Next is 1/2. So here, the exponent of 1/2 is 1. Therefore, the answer is 1. Next is when x is 1. So we have f of 1 is equal to the logarithm of 1 with base 1/2. And in getting the logarithm of 1, the answer is always 0. Next is when x is 2. So we have f of 2 is equal to the logarithm of 2 with base 1/2. And to find the value of this, we can apply the change of base. So I will use 2 as the base. So this becomes the logarithm of 2 with base 2 over the logarithm of 1/2 with base 2. Next is I will express 1/2 as 2 raised to negative 1, and here the exponent is positive 1. So we have this. And the answer in the numerator, applying the property of logarithm, it is the exponent 1, and in the denominator it's negative 1, so 1 over negative 1 is negative 1. Next is when x is 4. So to solve for the value of this, let's apply again the change of base. So I'm going to use 2 as the base. So we have logarithm of 4 with base 2 over the logarithm of 1/2 with base 2. Next is change 4 to 2 squared and 1/2 to 2 raised to negative 1. Next is to find the value. The numerator is 2, the denominator is negative 1, so the answer here is negative 2. After we have completed the table of values, let us now plot all of these points. We have 1/8 and 3, 1/4 and 2, 1/2 and 1, 1 and 0, 2 and negative 1, 4 and negative 2. The third step, we connect all the points using a smooth curve. So here is the graph of our function logarithm of x with base 1/2. Now, let us find the properties. So for this function, as you can see, as x increases, y decreases. Therefore, the behavior is decreasing. This happens when the base is between 0 and 1. Next is for the domain. As we can see, the values of x are found at the right of 0. Therefore, the domain is x is greater than 0. As for the range, since the graph continuously moving upward and downward, the range is the set of real numbers. As for the intercepts, the x-intercept is present, which is at this point 1 and 0, while the y-intercept is none because the graph did not touch the y-axis. Next is for the asymptote. As we can see, this graph did not touch the y-axis or did not go beyond the y-axis going to the left. Therefore, we have the vertical asymptote at x equals 0. And as for the horizontal asymptote, since the graph is moving upward and is moving downward continuously, then there is no horizontal asymptote. Let us now compare the logarithmic function and its inverse, which is the exponential function. So as we can see in our discussion, the domain is x greater than 0, the range is set of real numbers. And as for its inverse, which is the exponential, we just simply switch the domain and range. So we have this set of real numbers as the domain and y greater than 0 as the range. And if we're going to compare their graphs, it's very obvious that we have inverses. Like for an example, if we have here 2 and -1, on our other graph we have -1 and +2, which is the inverse. And if we're going to look at the line of symmetry y is equal to x, when you fold this Cartesian plane in this line, then these two graphs will coincide. Let us have another example. Find the properties of f of x is equal to the logarithm of x plus 1 with base 5. As for the behavior, since the base is greater than 1, then it is increasing. Next is the domain. Look at the graph. The values of x are found greater than -1. Therefore, we have x greater than -1. For the range, this graph moves downward, this graph moves upward continuously, therefore it is a set of real numbers. As for the x-intercept, as we can see on the graph passes through the point 0, 0, which is the origin. At the same time, this considers the y-intercept as well. So we have the same x and y intercepts. As for the asymptote, as we can see, we have a vertical asymptote at this point, which is -1. So this gives us the vertical asymptote x equals -1. And as for the horizontal asymptote, there is none, since the graph is moving continuously upward and moving continuously downward. So after giving you examples on how to graph and find the properties of logarithmic functions, here are the general properties. So if we are going to follow this y equals the logarithm of x minus h with base a plus k, here are the properties. For the domain, it is a set of x such that x is greater than h, so all you need to do is to find or locate the value of h. As for the range, it is always the set of real numbers. For the vertical asymptote, it is x equals h. Next is, there is no horizontal asymptote in any logarithmic function. For the x-intercept, you need to solve for x when y is 0. For the y-intercept, set the value of x as 0 and solve for the value of y. The function is 1-to-1 and it has an inverse function, which is the exponential. And for a is greater than 1, referring to the base, then the function is increasing. And if the base is between 0 and 1, then the function is decreasing. This time, let us find the properties of a logarithmic function without the graph. So the given here is f of x is equal to the logarithm of x plus 4 with base 2 minus 1. Let's begin with the behavior. In the previous slide, we discussed the general form y is equal to the logarithm of x minus h with base a plus k. In identifying the behavior of the function, we need to look at the value of the base, which is the a, and since a in the given is equal to 2 and a is greater than 1, then its behavior is increasing. Next, we have the domain. For the domain, we need to have the value of h, so we have the x plus 4. In order to identify the value of h, we equate this x plus 4 to 0, solve for the value of x is equal to -4, so the domain is the set of x such that x is greater than -4. As for the range of the function, any logarithmic function has the range, which is the set of real numbers. Next, we have the vertical asymptote. For the vertical asymptote, always remember x is equal to h. In this case, we have x is equal to -4, which is the same value with the domain. Next, we have the horizontal asymptote. Any logarithmic function doesn't have a horizontal asymptote, so the answer is none. Next is the x-intercept. To solve for the x value, we need to let y be equal to 0. In this case, the y is the f of x, so we have this. The next thing to do is to remove the -1, so this becomes +1 by transposing it to the other side. So we have the logarithm of x plus 4 with base 2 is equal to 1. The next thing to do is to change this logarithmic equation to exponential form. So this becomes x plus 4 is equal to 2 raised to 1. Next is to solve for x. So we have x is equal to 2 minus 4, and this gives us -2. So the x-intercept is found at -2, 0. How about the y-intercept? To solve for this, we need to let x be equal to 0. So for our function, it becomes y is equal to the logarithm of 0 plus 4 with base 2 minus 1. Simplify, so we are getting the logarithm of 4 with base 2 minus 1. To get the value of this, let us change 4 as a power of 2, so it becomes 2 squared. Applying the property of logarithm, when the base is equal to x value, then the answer is the exponent. So this becomes y is equal to 2 minus 1, and the answer here is y is equal to 1. So the y-intercept is found at 0, 1. After providing you examples and the general properties, this time you need to check your own understanding. Find the properties of each logarithmic function. You may verify your answers using a graphing software. You may pause the video to answer the following items. Let's check our work. For the first function, we have the following properties. How about for the second function? These are the properties. Did you get a perfect score? If yes, very good. What are the important concepts to take note? First, when we say logarithmic function, it is the inverse of an exponential function, and the logarithmic function is denoted by f of x is equal to the logarithm of x with base a, which can be changed to exponential in the form of x is equal to a raised to y, where x is greater than 0, a is greater than 0, and not equal to 1. And to graph a logarithmic function, keep in mind the following steps. First, make a table of values. Second, plot the points found in the table. And third, connect all the points using a smooth curve. And for the properties, following the general form, y is equal to the logarithm of x minus h with base a plus k. The domain is x greater than h. The range is a set of real numbers. Vertical asymptote is x is equal to h. There is no horizontal asymptote. X-intercept is the value of x when y is 0, and the y-intercept is the value of y when x is 0. The function is 1 to 1, and the behavior is increasing when the base is greater than 1, and the function is decreasing when the base a is between 0 and 1. This is the end of our discussion about graphing a logarithmic function and finding its properties. I hope you have learned a lot in this video. So if you're new to my channel, please don't forget to subscribe and click the notification bell to be updated for the next videos. Also, please don't forget to like and put a comment in this video. Bye everyone! See you in our next video.